Welcome everyone. Today we have another new episode, and I'm really happy. Today we have a very important guest from USA. We have Professor Rob with his excellent analysis. Already he become very famous in Asia Pacific, many university. Even before the show, I get call from Mahasa University in Malaysia, and they're really observing our show. Professor Fred Philip, he's a big inspiration for me. He's the chief of Tando, is another think tank, and I think everybody know about Professor Edward and his very interesting activities in policy level around the world. He's doing excellent work in Africa, in Europe, in USA, and other countries. So I want to start from Professor Fred Philip. Sir, we are discussing about cloud data. And important thing is that still Asia Pacific, they can engage with this kind of things. Even many developing nations, because our major audience and people actually come from developing nations. How we can understand about cloud data, how we can work, what is the opportunities we have?
Very good. Well, many things to consider. I think I'll often have to refer back to yesterday's panel on digitalization because the two topics are so closely allied. I think we can deal very quickly with the security aspect of this, because when your data is restricted to your machine at your home, then the vulnerability security issue is will somebody break into your house or break into your office? When your data is in the cloud, then, as has been obvious from recent news events, then it's vulnerable from hackers breaking into the provider's servers. So, okay, enough for the moment about security. The phrase cloud data is perfectly clear to computer scientists. To laypersons, it's a bit confusing. And the reason for the confusion is that, yes, the data in the cloud is the kind of thing that we normally think about, like Google's data about your buying behavior, the bank's data about your account activity, and so on. But to a computer scientist, it can also mean compilable and executable code, like the next version of Microsoft Word. All right, so keep in mind it's all zeros and ones out there, whether it's Google purchasing data or whether it's Dungeons and Dragons game or something like this. It's all just zeros and ones out there. So there's the convenience issue that you don't have to change. You don't have to do constant upgrades of your home laptop if you are using the word processing program in the cloud, like Google Docs, for example. You don't have that resident on your personal machine. So that's good, and it's productive for the individual worker, because I think we've all been frustrated by logging onto our, opening our laptops, trying to get some work done, and every program you open says, upgrade now, click here for upgrade. You know, they want you to upgrade every day. So many programs you use, and you think, how am I ever going to get any work done if they want me to upgrade all the time? There's a very important reason why we're doing cloud computation and cloud data storage right now, and I think it would take me a few minutes to describe it. So for the moment, may I give the floor to
Yes.
The other panel members and come back to this other item after a while.
Yes. Okay, Professor, it's up to you. No problem. Professor Rob, how do you want to analyze this cloud data, how it works, how it will be helpful for our business process.
Well, what the cloud provides is economies of scale for IT infrastructure. The big providers, at least here in the U.S., are Google, Microsoft, and Amazon AWS, Microsoft Azure, and of course the Google Cloud. And this aggregation allows them to provide services at a cost-effective rate. So at least when it comes to an engineer doing a program, they can provision a virtual server. That's a server that lives in a rack. It's kind of rented out. You pay for it by the amount of time and amount of data that you put through it. Really, the tariffing it can vary a bit between providers, but the end result is you, without having to put up a workstation yourself, you can access a significant amount of resource. Everybody else kind of vanished. Are you guys all still there?
Yes. Here.
Yeah, what you've done makes it look like I'm here all by myself all of a sudden. All right, so so it allows for that aggregation. Now, some of the stuff that you're balancing, and Fred mentioned it, is security and control. So you've got this kind of fight between on-prem, short for on-premise, and cloud, and then of course the big thing right now is hybrid, where the capability migrates between the on-premise hardware and the cloud hardware depending on need. And so, like for a lot of companies, you have different kinds of loading. You might have a graveyard shift that can use the equipment at night, and then the full shift during the day. And during the day, you might have plenty of resources on premise, but excuse me, during the night, you might have plenty of resources on premise, but during the day, you might spike. And during that spike, you'll use the resources seamlessly in the cloud. There's also kind of a cloud hierarchy now. The providers that I just mentioned are generally referred to as the mass of the public cloud. IBM has positioned their cloud offering as the secure offering for the environment, predominantly focused on government, healthcare, and finance, with a lot of emphasis on the finance and banking side, as a way to differentiate. It's an interesting dynamic. Oh, one of the other things is people have found that often the on-premise approach at scale is cheaper than the cloud instances, the cloud implementation on scale, predominantly because then it's the extra tariffing and profit that Google, Microsoft, and Amazon takes against an equivalent economy of scale. So economies of scale means once you get to a certain size, the cost for each individual item is minimized because you're making so many of them. And the cloud has that advantage, but some corporations can develop and deploy hardware at that same scale, and then it's cheaper for them because they don't pay the overhead of the cloud provider, plus they get some control. Now, one big change we had recently with the pandemic is we didn't have anybody to really work on the on-premise hardware. And that became a huge problem. So right now, the focus is really moving as much stuff in the cloud as possible because people are anticipating future pandemic events. And by doing so, removing the loading on the people that need to go into work and actually work on this hardware. So we've got that newer dynamic. For newer economies that are coming up, the cloud is particularly attractive because it's kind of a generational jumping effort. Plus, you can better physically secure the hardware. There are theft issues and there are physical access issues that we deal with security. There was an old story a while back about a couple of Google engineers that were using their access to get private information on some of the women that were using the service. And my best security story with regard to people getting fired were a couple engineers in a pharma company using cloud resources that turned out to be in Eastern Europe to work on a very proprietary drug. And the story was they got an award for cost savings because it only cost them something like $3,500 to do the work, where if they'd done it on-prem, it was estimated to cost close to $200,000 to do the work. But because the data went to that Eastern European facility, they couldn't secure it, and that breach of security cost them their job. So there are a lot of stories like that. The cloud has matured a great deal since then, but if you're emerging, probably looking at cloud infrastructure as a way to do so at scale safely and for the lowest cost per working instance possible. That's it for me for now.
Thank you. Thank you. Professor Edward.
Well, these are very insightful comments, and I bow to the two experts that are on the show here with me. Maybe I can just do a little bit of putting this discussion in context, because we talked last time about digitalization, and what we're talking about with cloud storage is, of course, storage of data. So for those of you who are older, you probably remember that it used to be the way we listened to music was we had CDs. I still have some right here, and these include zeros and ones, so I can listen to my favorite music. There's Wagner and Parsifal. One of the ways you can listen to books is this way, of course, on CDs. But now we basically have things like Kindle, though there you can download it, onto your device. One of the ways we used to consume movies was by DVDs. We still have these around. And one of the ways we store data is a little thumb drive here, which I still have. This I think we can go up to a terabyte now on the thumb drive. And so we've seen the evolution of storing data. And if I had time, I would have gotten one of the little floppy disks and held it up and told you how little data it actually contains, and how everyone was so excited when these came out, when the little 3 point whatever it was came out. Everyone was excited about the storage capacity. And of course, what my associates here have said is quite correct about how it's expanded, that the digitalization has expanded to the point where now we have the cloud, and now it is not just a matter for storing entertainment. So I can simply listen to something streaming when I'm jogging or when I'm sitting here, but we can do work. We can do good industrial level work with the cloud. One of the issues that's come up in past discussions, and Fred Phillips has alluded to it quite correctly, is the security issue. And to me, that's one of the big issues, is the advantages of for example, using software as a service instead of having to download all sorts of programs is a growing industry, where instead of me just putting it all in my laptop or even into my smart device, I can simply essentially use the software service. In fact, I'm looking to do that right now with my own organization as I build it. But one of the concerns, of course, is security. We saw in the United States over the last week, hackers essentially taking control of a major pipeline and holding it for ransom. And we have gas shortages and gas lines now in the United States because of that. I think the pipeline is up now. And we've seen examples, a lot of examples in the United States, and I'm sure in other countries as well, of hackers taking control of local databases. In the District of Columbia, Washington, D.C., right near where I live here, hackers have taken control of personal information about all the police officers in the city, and is threatening to expose that information and endanger the police officers. And so to me, the advantages of the cloud are incredible, as we've heard. But I think one of the big discussions is going ahead is going to be a matter of security, and especially when you're dealing with manufacturing, industrial, and other uses like that, then it really becomes important. It's not just about someone hacking my computer and getting my personal information, which is bad enough, but doing what we saw with the pipeline and so forth. So to me, that's going to be the big question a lot of companies, I think, are going to be looking at.
Mm-hmm. Thank you, Professor Edward. Professor Fred Philip, I think you want to add some new point on cloud data.
On what Edward Hudgens just said, I think that the care that companies take to ensure the security of your data is going to be a major component of those companies' reputation in the future, and the willingness of people to deal those companies. Um, my co-panelists this morning were kind to use the word expertise. Most of what I'm telling you is things I remember from an undergraduate minor in computer science more than 40 years ago, and just keeping an eye on things since then. But if I preface what I'm going to say with a little bit of that history, of course, I think all three of us, when we were in school, write programs on punch cards and submit them to a mainframe hatch and wait overnight for the results to come out. So there was no data communication to speak of, except
And
between.
Fred, remember, we turned in 500 cards, and one of them had one error. And so hours later, we go back, and it's that one card that blew our whole thing out. So we had to go through the whole thing again.
Oh, absolutely. That's the way it worked. And, you know, as undergraduates or grad students, we were such cheap labor that our professors, you know, what the hell? But anyway, there was no data communication to speak of except, you know, between the card reader and the mainframe. And then some of the installations had began to install dumb terminals outside the mainframe enclosure. And so there was really no local processing power in the terminals, and there was rudimentary communication between the terminal and the mainframe. And this was pre-internet, so there was a lot of analog digital conversion and fairly slow communication between the two machines. So you can imagine how delighted I was when personal computers first came onto the market. It didn't have to do that dance with the punch cards that Edward was describing. And wow, all that computation power right in my own home. And then the Macintosh and the Lisa in the early 80s, and I could do graphical computing, and wow. And I was so enamored with that I didn't care about data communication at all. And in fact, the early PCs had no ports for that kind of communication. All right, then we started connecting these things to the internet through you know, analog modems and the telephone lines, and the communication was very slow, but Moore's law was chugging along, and the local computational power on my desktop was getting more and more. And despite the bloatware phenomenon, I just really enjoyed that. But dealing with you know, the hiss and pop pop of the telephone modem was always a little frustrating. Okay, and then the communication got better. The bandwidth situation became easier, and somebody decided we could have something called thin clients, make the PCs stupider, and depend on the. So, what I'm saying is that there were cycles back and forth because the pace of progress of Moore's law was not always in sync with the decreasing cost of bandwidth, the cost to transmit so many kilobytes per second. So there was always a back and forth between, is it more economical to have more local processing power, or is it more economical to have less local processing power and depend more on the bandwidth to communicate to some central processing capability? Okay, so now we are sort of coming up against the brick wall at the end of Moore's law, and bandwidth is, if not getting cheaper, at least, you know, as the companies foist 5G upon us, the bandwidth might be increasing. So the economics, it's not just our personal need, as Rob said, but the economics point to cloud computing, because we're not going to, now there's exceptions because Intel is working on a new chip architecture that might push the Moore's law brick wall a little bit farther. But assuming that Moore's law doesn't have a whole lot of life left in it, then the economics point inexorably toward cloud computing because of the relative cost of bandwidth against the cost of local computing. This has been my thinking, and if I'm wrong about it, I'm very willing to be corrected.
Thank you, Professor Fred Philip. Professor Rob, I think Professor Fred Philip gave us some idea, the progressions in modern science and engineering. What next?
Well, he's right. There's been kind of a bounce back and forth. Back in the time of IBM and Fortran 4, when we were all doing punch cards, the computing technology was relatively centralized. The business model was a services model, not a hardware sales model. And then somewhere around 82, 83, IBM got the brilliant idea that this great revenue model that allowed them to survive economic collapses and the stuff was not producing enough money. And so they started selling the hardware instead of leasing it and switched from a services model to a hardware sales model. And about a decade later, they almost went under. Ever since then, the market's been trying to find its way back. As Windows came up, we moved a substantial amount of complexity that was relatively manageable in the raised floor environment, and we moved it to the desktop. And there were a lot of us that were doing things that we probably shouldn't have been doing on PCs at that time. A lot of the accounting, control, management capability moved to PCs, and they were pretty much crashing all the time. And mainframes were up. The thing we had with mainframes we came to love was the fact we could depend on them like on utility. And something broke was generally a coding problem. Though I did have a friend that played Star Trek on a mainframe and took down the entire West Coast, but that's a whole different story. And so we've been trying to find our way back. Fred mentioned thin clients. That was one of the first efforts when Oracle and Sun Microsystems thought they could take out the PC and give people something that was kind of a blend of a terminal and a PC where all the processing occurred centrally, on premise, but centrally. The problem was is the hardware they were using, the server hardware, couldn't multitask, and it didn't have the I/O capability necessary to handle a whole bunch of people pounding on it at once. And that was probably in the mid to late 90s that happened. Both efforts failed. You could argue part of the reason that one of the efforts failed is because Larry Ellison put his girlfriend in charge of it, and she was a school teacher with no experience in IT, but she was good looking. In any case, and so that kind of failed. Though thin clients have remained in market pretty much a steady pace since the late 90s. Till the 2010s, in terms of market placement. They were good for people that didn't have to do a lot of computational work. Call centers used them for the most part, and they had the advantage of being somewhat more secure. When they were deployed in India, for instance, a bunch of the thin clients were stolen one day from a company, and they got them back the next day on the sidewalk because the people that stole them couldn't figure out what to do with them. What was the nature of the thin client? If you didn't plug it into whatever it was supposed to be hooked into, it didn't work. It was pretty much a remote monitor, keyboard, and mouse. But that got everybody kind of still thinking and swirling around the idea. We'd like to go back to this idea where the complexity was centralized and the overhead, as Fred pointed out with regard to patching. I think it was Fred that pointed out with regard to patching. Was contained by the IT organization. We just had a Colonial Pipeline failure out here. At least the current analysis is it was a phishing attack where somebody came in with an email that had a payload. The individual in the company clicked on the payload went off and infected Exchange servers that hadn't been properly patched, and that's how it spread through the organization. But it points to the weakness on both sides. So certainly a weakness in the client, the user who clicked on something that was malware, but also a weakness at the back end where the patching hadn't occurred timely and those servers were vulnerable. In a cloud environment, the cloud provider may or may not do that for you. It kind of depends on the implementation. But what we're moving to is a model where the cloud provider does take care of that for you, where you basically get computational power and capability as a service, and the cloud provider takes over the heavy lifting of maintaining, patching, and updating that hardware, and you just pay a monthly fee for the services that you use, and you don't have to pay what's called capital expense or capex to actually put the hardware in place. And companies are measured on their OPEX, their operating expense, the day-to-day expenses they have, and they're measured on the capital expense, the major expenses and purchases that they incur. And the difference being that the OPEX is relatively steady and tends to go up and down based on the loading and profits and staffing of the company, while CapEx tends to spike, occur once every 2-3 year period of time, depending on what it is you're buying. And it's much harder to budget for, and it's much harder to apply those costs at a department level, which is what you kind of want to do, to spread the costs and put them down where the revenues are. It's called matching. But companies like it because it makes the company a lot easier to manage. So having said all that, right now, as I mentioned, the emphasis is to try to put as much stuff in the cloud as possible and have that new OPEX now match the loading of the company, so it goes up and down based on need and doesn't go up and down based on like CapEx does with regard to purchases, and kind of even out the revenue stream. My expectation is this is going to bounce back and forth for a while. I mentioned earlier hybrid cloud, which is kind of the current thinking for where most people want to be, where they have hardware on premise and they have hardware in the cloud that's virtual, and they switch back and forth as the need requires it. But as I also pointed out, the pandemic is pushing everybody hard to the cloud at the moment, because what it does is it allows them to free up people where they're not really sure where those people are going to be, whether they're going to be working from home or on premise. And it's pretty hard to do on premise support with remote people. We do have robots. There have been several efforts to develop robots that go into raised floor environments and do maintenance, but they basically do things like adjust the air conditioning temperature and redirect air for hotspots. We haven't reached the point where they can pull and remove cards and replace cards and deal with the physical aspects of repair in a raised floor environment. So once again, we go back to the cloud environment. The cloud environment are these massive data centers, very secure, very clean in terms of practices, and it's just felt that cloud providers are going to be better able to weather pandemic-like events than individual companies, because the entire site is relatively sterile, as opposed to just the IT portion or the manufacturing portion of the sites in the remote client locations. So it's an interesting environment to be in. As I mentioned earlier, if I was going to deploy right now in a country trying to come up to speed on technology, I'd be looking really hard at cloud. Might be government cloud initially, where the government funded, secured, and provided it. Depending on my funding level and capability, it might be I'd look for outside providers, depending on where my relationships are with the West or the East, to do that for me. But gaining that scale, and particularly gaining the physical protection of the plant site, and being able to secure it against things like power outages better, would be my goal. And one of the issues that we're talking about with regard to doing this stuff centrally was data bandwidth and transport costs, but the bigger issue was latency. But with 5G and the following technologies, we pretty much got latency beat. The test cases with centralized cloud gaming, gamers require very low latency in order to compete. But the cloud gaming implementations from both Sony and Microsoft have actually held up relatively well, indicating we can get latency down to a point where most users probably aren't going to notice it, and be able to survive in a cloud implementation. So the hope is by the time we get to 2030, most of us won't have PCs in our homes anymore. We'll have a data service in the cloud, and we'll be subscribing to it. And we may not be working in the office. We might have several jobs working for several different companies remotely, but that's a whole different story we'll deal with in some future session.
Thank you, Professor Edward.
Yeah, interesting. By the way, Fred, I still have the big physical tape that when I did my doctoral dissertation on from a dumb terminal. It's somewhere in a closet somewhere, I don't know where, but so I went through the same process that you other gentlemen went through. And in terms of latency, one of my 10-year-old daughters who likes to play games on her laptop or on her tablet is now petitioning because the thing isn't fast enough and the latency is a problem. And so I may have to get her a new tablet. But anyway, but I want to put this into, again, to provide some context here. And I bow to Rob's expertise on the business side. But let's say you're a business or a startup in the Asian Pacific region. First of all, there's a good chance you're going to want to work internationally. You might start in your own country, whether it's Bangladesh or Malaysia or wherever it happens to be. But as you grow, and as a lot of companies are in the process now, hopefully listening to this broadcast, the streaming, you're going to want to work internationally because globalization is the wave of the future, and therefore, obviously, having having information and data and access to the cloud is going to be important. I want to put it in the context, though, of I'm going to read a quote that I've read before about the fact that data now is being collected from millions and millions of sensors. And this is a quote from Business Week from a few years back, and it basically is, in the next century, planet Earth will don an electronic skin. It will use the internet as a scaffold to support and transmit its sensations. The skin is already being stitched together. It consists of millions of embedded electronic measuring devices, thermostats, pressure gauges, pollution detectors, cameras, microphones, glucose sensors, EKGs, electroencephalograms. I could go on and on. Traffic monitoring and so forth. And the prediction is that I think right now we have it for 15 or 20 billion sensors providing data, and it's going to probably grow. The prediction I've seen is something like 500 billion sensors providing data by 2030 or somewhere in that neighborhood. So you're talking about cloud storage and how businesses can use cloud storage. Think also about all the places where data is being collected, where it might go, and where if I were let's say I'm an entrepreneur looking at biomedical things, which is an interest of mine, and I might say, well, let's see, where can I get information and data on big data on things like how people react to certain medications, or what is the cost of certain kinds of treatments or whatever. I want to pull it all together because I want to create an innovative way of dealing with with medical issues. I just texted somebody on Capitol Hill yesterday. I won't say who it was because I was doing some policy work on how to provide health care benefits for retired postal workers. And it's a huge cost. It's one of the reasons our postal service is bleeding money. And so I sent some information and said, well, take the following. Consider that we have wearable diagnostics now, like an Aura ring, which can detect sleep issues, but we're going to EKGs that on smartphones, and it's only going to be expanding. Then consider that we can sequence a human genome, not for $100 million like in 2001, not for $10 million like in 2007, but under $1,000 today. So we can sequence your genome, get all that data about you as an individual. And then we can have real-time monitoring of your bionics, okay? And you can have AIs that now understand all the particulars of you as an individual. So what if I, as a business, want to come up with a model that's a healthcare model rather than a sick care model, where I'm being monitored in real time and my data is being compared to other people so the AI can make discoveries about, oh, well, look, it might well be that these indications in Ed indicates that he's going to have a heart attack, so we better get the medics out to his place. What if I want to create a whole business doing that? Well, you can see where pulling data from all sorts of sources is going to be absolutely crucial. And while I like to keep some of my photographs on a thumb drive in case my computer crashes or in case somebody hacks the web, this is all nice for my little pictures of my little daughters. Obviously, if you are a business in Malaysia or anywhere else, you're going to be, and an entrepreneur, you're going to be looking at, well, I need data from here, I need data from there, I need to pull it together in certain ways. And of course, I need to process it. So how am I going to take all of these things I've just discussed and pull it together and do the analytics and then do the economics of how you can provide that service and so forth? And in all of these cases, you're talking about software as a service, you're talking about access to data, et cetera. So all of this is really kind of dependent on the cloud that's pulling in the data from potentially 500 billion sensors.
Mhm. Thank you. Professor Fred Philip, like as we are discussing about uplifting the present conditions with utilizing of AI, big data, and cloud computing and other things, what is your advice for Asia Pacific? How we can uplift uh, our organization, especially small and medium organization?
Was just proposing that in this context, I suppose we should also touch on the environmental issues attached with cloud data. There's the data centers use a lot of energy, especially if they're used to mine bitcoins, and they throw off a lot of heat. So people are establishing data centers in northern Finland, and I have a friend who has one under the Swiss Alps, and this does not present too many opportunities for Southeast Asia unless you can find a way to submerge the data center in the cold, deep ocean. For Nepal, obviously some opportunities, right?
Mm-hmm.
The data does no one any good while it's sitting on the servers. It has to be communicated. And there are also environmental issues attached to the transmission. The transmission, as well as the latency and so forth, is supposed to be improved by all these satellites that Mr. Musk wants to launch. And this has its own dangers. The Chinese rocket that crashed in the Indian Ocean the other day is just an example of how one of those dangers was narrowly avoided. Do I need 5G at home? Actually, I don't. 5G is really good for manufacturing operations and fairly useless in my home. I know I'm sounding effete because I think that downloading entire movies in real time is a rather superficial use of the internet. In fact, my wife and I are at this very moment doing battle with a rock squirrel in our front yard. And both of us thought at the same time, oh, we ought to watch Caddyshack again. And my first thought was, okay, I'll go to a store and find the DVD of Caddyshack. It doesn't occur to me to try to download the movie over the internet. That's just the
stream it.
Yeah, I could, but there's another one of the fellows of the Tando think tank / consultancy has just petitioned the FCC to put a temporary halt to more satellite launches. The dangers are, these crashes that lead to the Kessler syndrome, where fragments of one satellite collide with other satellites, creating a cascade of satellite fragments that could bring down the entire world communication system. And this danger is heightened the more, Musk and the others are considering ultimately having 100 times more satellites than in just a few orbits than the ones that we have now. The weather forecasters are up in arms because the frequencies of some of the 5G bands are going to interfere with weather forecasting, and they say throw it back to the scientific state it was in excuse me, in 1980. And the astronomers are up in arms because all these satellites not only block their view of the heavens for research purposes, but hinder their ability to identify rogue asteroids and so forth that might be a threat to the Earth. So, every interest group is interfering now with every other interest group because the world is so tightly connected. And the environmental impact of the data centers is one thing, and the environmental impact of the data communication is something else. And I don't know the answers. We have tried, or rather, this Tondo fellow has tried at least to put a halt to the actually illegal actions of the FCC because these indiscriminate permissions for more satellite launches actually violate international treaties that the United States has with other countries, and it goes beyond the charter of what the FCC is supposed to be doing. So, without going into speculation about who's paying off whom, these are things we have to attend to, and we have to figure out, at least according to this Tondo fellow, whose name is Gresser, which parts of the world are best served by satellite internet, and which could best be served by land-based fiber optic and so forth. And the balance should be reached. Nobody's interested in confrontation here, and certainly there's a place for satellite internet. But if we can get parties together for some dialogue and try to minimize these, and I haven't even touched on biological effects of the 5G bands, which some people think is a conspiracy theory, so I won't even go there.
Thank you. Professor Rob, I want to ask you one question, because this question I get a lot of professionals from Malaysia. They are in mid-age. They want to shift their career. Let's say they are in medical industry. They want to engage with AI and technology, or they are in business industry. They want to engage with different kind of technological improvement. Let's say cloud computing, engineering, and these things they want to develop. Number one, is it practically possible? If possible, then how they can do it? Because we always get huge question from the industry. Especially they want to know more from our panelists. Even Professor Edward and Professor Fred Philip can touch this question, because this is the burning issues right now. Because of the COVID situation, many people lose their job. Many people feel that technology is more important. We have to upgrade ourselves. What is your advice?
Well, okay. So whenever you have an expertise in one area or a market, and that market's becoming saturated or unattractive, or whatever the situation is that these people want to address, you need to look at adjacency. So you're looking for adjacent markets where most of your skill sets will transfer. The greater the difference in what it is you're anticipating doing, the more risk you're going to take, because you don't know what you don't know. And so you want to move gradually into areas where your lack of knowledge isn't going to do you a great deal of harm. Everything looks good on the other side of the fence, but until you get there, you're not going to know what the difficulties are, and that's why you want to move gradually and adjacently to areas that you can better understand. So, for instance, if you're in foods, for instance, and you're primarily into restaurants, you might look at food outsourcing, providing the food services for hospitals or military organizations, because the skills of logistics, of cooking, of preparing, those will transfer. You'll have to learn how to do business with those different entities, and you'll have to learn how to do scale. But that'd be a lot better than suddenly deciding you wanted to build rocket cars. So that's because you would have no experience in moving to aerospace. And so you're looking to find instances where you can use the majority of your skills, but the market's new and virgin. You do need to spend some time looking at the competition. you may be running into a market that is dominated by a couple large players, and where the cost of entry is going to be so high, it's not going to be worth your while, or you simply can't get to the economies of scale. One of the difficulties is if you're moving into an area where it's dominated by a particular company, that company has so much business that they can charge less than you probably can charge because you don't have that same level of business. You can't spread your resources over the number of customers that they can. Plus, they can probably lower their prices to address what it is you're trying to do long enough to knock you out of business. And in some countries, the antitrust protections that keep them from doing that are pretty light. So you do have to analyze the competitive structure before you're going in. Another thing you can do is you can disrupt. You can take a look at your industry and say, okay, here's what the cost structure is. Here's what I could do to change that cost structure. And using foods again as an example in the pandemic as the cause, what's happening in a lot of restaurants is they're exploring robotics. So they're going in and automating a lot of the functions. So a lot of the repetitive jobs are now done by machines instead of people. And during a pandemic, of course, machines don't get sick. And so you can keep operating even during that effort. There's also a pretty big effort, for instance, here in the States to raise the minimum wage, and a lot of food workers work at minimum wage. Another thing that's promoting this idea of using robotics to spread to reduce the cost at scale, though surprisingly enough, the robots are still more expensive by a substantial margin than the people are. It kind of shows how off-putting some of the lower wages are, at least here. In any case, so you're looking for those adjacencies. I do want to make a couple corrections from some of the prior comments that were made. In terms of latency, the latency that we're talking about is transmission latency, not computer performance latency. And you want to keep those two things rather separate. Fred was talking about not needing 5G. 5G has some alternative benefits that would suggest otherwise. One of them is performance at the edge, particularly in the countries you were talking about. The issue is for some of the regions, they don't have internet connectivity, or if they do, it's really bad. And 4G and 4G LTE have poor performance at the edge. And what I mean is the edge of the reach of the network towers. 5G has much better performance at the edge, and it's higher in security as well. And a lot of these environments have fairly serious security problems already in the environment, and 5G may or may not correct them depending on what the problems are. But we have a serious security problem at the moment, and that's probably one of the things that's going to be driving, going back to the topic we're talking about, cloud data. Is the idea that at least for in the small to medium business range, a cloud may be able to better provide protection for the data and the hardware than individual companies can. If you think about it, a lot of small storefronts or whatever, that they just can't provide the level of environmental protection or physical protection that a large site can with dedicated security. We mentioned power. A lot of these data centers are positioned against or are installed against hydroelectric plants whenever possible because they're installed where power is cheap. There was a mention of crypto mining and the impact it's having in the cloud. Not as much as you might think, because often crypto mining to be done, and I've actually done testimony on this, a lot of crypto mining to be done requires dedicated hardware to be done economically. The cloud provisioning, the cost of using the cloud becomes so high when you start provisioning for crypto mining that it's hard to see, particularly with the very volatile cyber currencies, that you're going to make money. And at least here in the States, based on my experience, there's an awful lot of litigation going on around people that feel they've been taken advantage of by what amounts to cloud providers of crypto mining technology. So I'm not so worried about crypto mining with regard to the cloud. It's having a massive impact, though, on hardware availability, particularly graphics cards at the moment. And Musk is right, though he was untimely in saying that it's pretty hard on the environment, because I think right now it's consuming something like 40% of the world's computational power and related energy use, which is problematic on a whole bunch of scale. And of course I view it as a big Ponzi scheme anyway, because there is nothing really underneath this currency to maintain its valuation, and governments don't like it, and it's predominantly used for illicit transactions. But it's an interesting technology, and the blockchain stuff that surrounds it is really becoming the foundation of banking at the moment. One final comment. as we move into the cloud and into the future, and we move into AI, one of the big implementations of cloud computing, and I'm moving from cloud data to cloud computing because they really are kind of different, is the fact that you can centralize an AI resource that is so much greater and better than Siri, Cortana, or OK Google, which is basically a scripted front end for a web search engine, and provide the kind of information that people need when they need it. But that'll open up a whole bunch of different doors with regard to bias, focus, compromised AIs that we'll deal with in the future, and probably on a talk on again on AI ethics, which I think we did a few weeks back. But at the end of the day, and back to your original question, if you're going to expand into other markets and other areas, look for adjacency. Look to take the skills that you have and apply them in a market area that has an exposure, or look to disruption. Take the market that you're in, apply technology or something else to it, and disrupt it. Apple demonstrated that with the iPhone. Microsoft and Intel, and strangely IBM demonstrated that with the IBM PC in the day. And then Amazon most recently, and of course Google with web search and controlling market revenue, and Amazon with regard to cloud computing, disrupted those individual markets as they came, still in the same kind of space that they were. In fact, Google's interesting because they took the IT skills that they were having to deploy at scale for the Amazon marketplace, and then decided to market them out. And almost everybody before it failed at doing this. And they did it successfully and at such a scale that they scared the holy crap out of every other computing company out there. And now we have a race to the cloud. And if it wasn't for Amazon, we probably wouldn't.
Mm-hmm. Thank you, Professor Edward.
Sorry, I was muted there. Yeah, just a couple of comments to follow up on these comments. As you may gather from the artwork on my wall, my original major was physics and astronomy. So I am very sensitive to being out there with a telescope in the middle of nowhere at 3 in the morning, and whether there's going to be lots of satellites going through my field. And of course, obviously for serious astronomers, it's a serious issue. And I could go over some of the other serious issues about having lots of satellites and stuff up there. Space debris is a problem. I did work, policy work in this area in the past. But that being said, these are the kinds of adjustments that go on with any transition in an economy. And so my feeling is I adopt, rather than the precautionary principle, the proactionary principle, meaning let Elon launch all that he wants. And then if you see some really serious problems, okay, let's work them out and deal with them. I'm hoping to have habitats in orbit and on the moon and Mars and everywhere else. And yes, we're going to have some challenges and we're going to have to work around those. And so fine, that's what you do. But I don't want to stop progress because we think we have a problem. Let's work the problem, so to speak. But
we should probably do a future program on space exploration, but we probably ought to keep the kind of cloud data for this one. I mean, I know. We're just kind of all over the map all the time, and I just think for folks listening, they're expecting a discussion on cloud data, not satellites and.
I know. Okay. It's fine. Well, but actually, Rob's point is very good. And this is one of the things, part of the genius of Sharif here is that he understands that all of these issues are connected. If we're talking about cloud data, then we're talking about billions of sensors that are pulling in data, and how can you, the entrepreneur, use the data and access the data, and is it secure and so forth. So all of these things work together. But in terms of his particular question about being an entrepreneur, and especially in a time of a pandemic and the transitions that we're going through, I agree, of course, with what Rob said on this. I would suggest, if I had to say to your audience, take an afternoon and either read or I actually have it downloaded, the audio version downloaded on my phone here. The book by Peter Thiel, who's of course one of the great venture capitalists, co-founder of PayPal with Elon Musk, 0 to 1. It's a very interesting book because he talks about exactly these sorts of things, about what's the best business plan if you want to disrupt, how you have to be careful about saying, for example, if you're an entrepreneur, let's say in some country, and you say, you know what, things are going bad for what we're doing now. So maybe if I can just get a small percentage of this huge market, well, good, I'll make out that way. And Peter Thiel goes over specific reasons about, for example, why some of the green energy initially failed because of the way companies were thinking strategically and not very well. So I would highly suggest that your listeners take an afternoon or a couple of days to look at Peter Thiel's book, 0 to 1, because it addresses exactly these kinds of questions that now are central as the pandemic sort of undermines traditional businesses and what they can do. And so they're looking to how can they provide services elsewhere? How can they diversify perhaps? How can they take their skills and use them in some other way that doesn't necessarily involve dealing one-on-one, where you can, and this is where, by the way, access to the cloud becomes extremely important because you're going to be using it a lot more than you did in the past. And this also points to the importance in the long term. Again, I know that we're kind of getting away from the cloud, of an education system that doesn't just train in narrow skills, but that robot proofs people so that they have the flexibility of mind and the entrepreneurship of mind to deal with these kinds of transitions. I mean, think of it this way: all of the discussion we've been having in this and other sessions have concerned transitions. How, for example, hardware was the big thing. IBM thought that they would make the money on, and then Bill Gates came along and understood, it's software, and he did his big deal with Windows, where he licensed it rather than simply sold it to IBM. That was a transition. We've gone through all these discussions of transitions. In a sense, market changes can drive those kinds of transitions and needs for businesses to think, diversify, or think out of the box, or look for other opportunities. And the pandemic is doing that. The pandemic, of course, is doing it in a way that we would prefer not to happen because so many people are getting sick and dying. But in a sense, the mechanism of, well, we're a business. I've been doing this for the number of years. Now I have to figure out how to do something slightly different because of the fact that we can't deal, one-on-one. You have to think that way, whether it's facing a pandemic or a market change or whatever it happens to be. And that's why, then again, that talks to the centrality of the fact that we have data now that is not just in your PC or in your thumb drive or whatever, but that you can access in the cloud. It makes it even more important.
Thank you, Professor Fred Philip. So there are many interesting points.
Yeah, I probably have to get off in about 5 minutes, so I'll just
okay.
Right here.
Okay, well, thank you for your comments, Edward. So where I was going with that environmental discussion is, Sharif, you asked about opportunities for Southeast Asia, and as is always or often the case with technology follower countries, you can observe what mistakes the technology leader countries have made. And in this case, I don't say they were all mistakes, but perhaps unintended consequences. And you can find, you can start businesses that build things for your region that are, cleaner, more appropriate for the region, and so forth. The satellites, Edward, I have to disagree a bit because, even back in the late 1980s, I remember my mentor at the University of Texas working with Hans Mark, who had been the NASA administrator, famous guy, to make a plan for the space junk problem. That was, what was that? Okay, more than 30 years ago. What was done in the interim to solve the space junk problem? Nothing, because it's one of these public versus private economics free rider type problems that, that's hard for somebody to make money cleaning up the space junk. So I believe it does have to be proactive and not just wait to see what happens, because we started to see what happened a few days ago. There's also the question of satellite security, and I'm speaking from a position of ignorance here and certainly oversimplifying the problem. But if a hacker or an attacker uh, meaning either a state actor or a non-state actor, knocks out a satellite through a software intrusion. Um, well, that is much more expensive than the vandal who cuts a fiber optic cable where you have to send out a few guys with shovels to fix it. I mean, the difference in expense of fixing this is huge. Um, thanks for pointing out Tyle's book. I think I will look at it because, frankly, Tyle has always struck me as a wacko. And working with Elon Musk, I don't know if you've ever seen the interview, the dual interview of Elon Musk and Jack Ma. And, you know,
It's
Jack
9
Ma.
o'clock.
Jack Ma was a literature major, and he doesn't always know the technical details of what he's doing, but he comes across as a very sane individual. And in that interview, Musk must have been out too late the night before or was stoned or something. And, you know, both of these guys, not Ma, but I mean, Tyle and Musk, give me the jitters when I hear what they're trying to do. Let me tell you a story about adjacency that reinforces Rob's advice about job changes. My graduate major was mathematics and operations research, and my PhD advisor told me to go to work for his friend who had a market research company. Okay, I'd never taken a marketing course, but this was the age where mathematical modeling was getting very popular in marketing circles. And this company had what was then the biggest private database in existence. And it was, by today's standards, it was laughably, ridiculously small. But it was, unlike in the internet age today, it was based on random sampling. So there was lots of scope for doing statistical work. And I enjoyed that. Worked for the company for 12 years. Came back and talked to this mentor at University of Texas, who at that time was mentoring also Michael Dell, as Michael was starting his little computer company out of his dorm room. And his mentor talked me into, make a long story short, talked me into working for him at his institute at UT. And he said, Fred, you know what you've been doing at that company all along is technology management. And I said, it is? Well, okay, I've been acquiring computer systems for the market research company and so on. And he was conning me. My mentor was conning me because he just needed someone to teach the technology management courses. So he was a con man, but he did understand adjacency. And in each of these two cases, I was able to, easily slide from one job area to, and so it is easily possible.
Yeah.
Thank you.
Yeah.
Thank you. I directly want to go for the concluding remarks. I want to start from Professor Edward, then Professor Rob, and finally Professor Philip.
Okay, thanks. I have to get off very soon anyway. I'll just start with, by the way, Fred, your point is about the tragedy of the commons is correct about space. And it is something actually I've thought about. We have the same issue, for example, in the oceans, because I've looked at the issues about fisheries and so forth. And to me, the answer concerns some form of property rights, enforceable property rights, that deals with that problem. So I don't deny the problem at all. I think there's but I think we have to think about how the solutions are there. Also, we have to consider, for example, we discussed some of the downsides of the cloud and some of the issues there. But you always have to ask, what is the value that you're foregoing if you don't do something? If you decide, well, we're going to, for example, in this country, we've delayed some of the vaccines for what I consider to be very, very trivial reasons. And so we've had thousands of people getting sick and dying because, well, we're worried about there might be this little thing here. And again, something I'm very concerned about whenever you talk about, let's be careful about a technology because it may have adverse effects. Yeah, well, when they invented fire, it had some adverse effects. It could burn down a forest. It also could heat your food and so forth. So just as a cautionary note. I'll note, by the way, that we had an earlier discussion about nanotechnology and materials. And so I think, Fred, the situation might be solved in terms of satellites when we get a space elevator, which is now becoming, this is a 20-year-old book. And I talked to the authors of this book back when it came out because I was doing space policy. And it wasn't possible then because of the materials issue. But maybe in the future, maybe in 10, 20 years, we'll actually have space elevators. So this will be moot and we won't have to worry about it. But I want to just summarize the issue about the cloud. I've put this in context again. This clearly, with the growth of data, and I've noted the growth of sensors, billions of sensors literally pulling in data from every imaginable place, and the need of businesses and entrepreneurs to be able to access that data and say, well, hey, I can use this for this purpose and this for that purpose, and I have to pull it together. The cloud is going to become even more important in the future. And so we have to secure it. And to me, that's really the big challenge. We're going to have, there's going to be a learning process, as with anything, about how best to access, about what services, can be offered, software as a service, for example. But that really is the future. And I congratulate Sharif for having this session and really focusing on something a lot of people don't think about.
Thank you. Thank you, Professor Edward. Professor Rob.
All right. So we're talking about cloud data. So just remember that cloud data is an aggregation concept where you take the data of multiple companies and you place it in the cloud provided by a third-party provider. We talked a bit about how that would be probably a better way to start if you're trying to build out an ecosystem now, because the economies of scale are strong. And because security and energy utilization, we didn't really get into the energy part as well as I would have liked. But right now, the thought is if you're going to build a large cloud data center, you'd probably tie it to a geothermal power plant, really green, and it can produce it 24/7, unlike either wind or solar at the moment, until we can go to going back to the space comment, unless we can get the off-planet solar to work. There is a chance of using wave motion generators if you're close to the ocean, but they've got some maintenance issues that are somewhat concerning, and they can become navigation hazards depending on if you've got a ship traffic in the area that have to be overcome. Right now, geothermal and nuclear remain the most promising for areas that don't have access to hydroelectric power. So it has some serious advantages. One of the things enabling that we mentioned before is the advancement in transmission technology, 5G at the forefront, but also moving to much faster wired transmission capability, largely using optical. The issue, of course, with any wired capability is you've got to protect it above ground or below ground. It just makes the wireless stuff a lot easier to implement where that infrastructure isn't in place and those trenches haven't been built. On the other hand, trenching does consume labor, and if the problem is mass unemployment, and part of what the government wants to do is employ people, then putting in place an infrastructure build-out program could certainly do that. Finally, probably the biggest area of advancement for cloud computing in particular will be artificial intelligence. That will allow the combination of this aggregation that Edward pointed to of data, world data, and the application of things like digital clones, which is where you build structures digitally that mirror their physical counterparts, and then you can perform analysis on the digital structures, and then use what you've learned on the physical structures to save substantial amounts of money and to better anticipate things like bridge collapses, which have been problematic both in the developed and developing world, as aging infrastructure has made its position in the world known as it collapses. So the final thing is the cloud still remains, I think, the economic future that we're headed for at the moment. And as I mentioned before, it has ping-ponged back and forth before, probably will again.
Mm-hmm. Thank you. Professor Fred Philip, what's your concluding remarks for today?
Well, I certainly agree with Rob about the cloud being the future. We haven't mentioned yet that it also, in a way, solves the the bring your own device problem that companies have experienced, having to support not only their own machines but every employee's individual telephone and tablet. If everything happens on the cloud, yeah, in many ways it's much simpler. I did want to go back to what Edward Hudgens said about trying to privatize the public cost of possible satellite catastrophes. Part of this complaint against the Federal Communications Commission, the FCC, is that they are not requiring that launch companies like SpaceX demonstrate that they are adequately insured against causing public disasters. So we hope that doesn't escalate the level of a lawsuit against the FCC. Right now, it's just a request for change of procedure. What we will learn from the pandemic is what are the best features of staying at home and working on Zoom, and what are the best features of working with others at the office face-to-face. And in the future, we will create a hybrid that combines the best of both. We're all tired, I think, we have Zoom fatigue and screen fatigue, and yet we've learned some ways in which we've been able to do things better during the pandemic through less commuting time, making a greater number of sales calls per hour when you're not physically traveling. And these are a few advantages that we've learned, and we will want to carry those advantages back to the office when travel restrictions ease. And I just will conclude with the hope that it will get better. And one of my countries where I feel at home is Taiwan, and they have been very lucky up until this week, and now the disease is spreading there. And of course, in India, it's really tragic. And I hope for the best for those countries, and that the new variants won't start sweeping the rest of the world also. But we will, after all the tragedies, will come to an accommodation and a better way of working.
Mm-hmm. Thank you, Professor Fred Philip, for joining today's sessions. I request all of our audience share our content as much as possible, and we need some of your support, because we are doing our fundraising for World Talent Economy Forum, because in Asia Pacific we are growing with academy, with different kind of summit and research related work. And definitely our world famous speaker like Professor Rob, Professor Fred Philip, Professor Edward, we need all of your contribution, because we are trying to develop a better knowledge-based community who can help us to solve different local problems with the global knowledge. So thank you everyone for joining today's session. Support World Talent Economy Forum initiative, and subscribe our YouTube channels, and share our content with your policymaker, with your school, college, university, with your corporation, with your government. And thank you, many of our developing nations government also joining World Talent Economy Forum. They are supporting, they are observing our session. Always they are communicate with our team that how they can improve healthcare system, education systems, or the technological part, how they can develop the better techno policies and other things. And I'm sure our mentors, Professor Fred Philip, Professor Rob, Professor Edwards, and all of the 300 speakers from 100 different countries will join in our community and help us to solve different problems. Thank you everyone for joining today's session. Thank you, Professor Fred Philip and Professor Rob, for joining today's session. Eid Mubarak. Thank you. Bye-bye and take care.